And now it is time to test if it's working. Okay, console disk, it's all attached. Get the input from the I/O expander, 0. Okay, so the black cable, the black wire is -1, so define that as TANT, define that as a constant, and I will call it pre for prepare the motors. Okay, now I will call pre to IOX, and that, whatever. Okay, I'm not sure what just happened, but all the motors look like they're in the right place. Are they? I'll try that again. Sometimes, what? Okay, why are you lit up? Okay, no, -1 is wrong. Actually, -1. So the last bit, I'll just do a manual test, that way I can show how to do that. This was just supposed to be a demonstration to see if they're working, and it failed already. Okay, so nothing's lit. Get a black wire so I can get the value. Now a lever. Okay, so if you call IOX, now it will, okay, so that's it. So then you can call that value onto the stack from that, or push it onto the stack, I guess. So, and you can use this notation instead of having to transcribe the number, just because it's much easier. I have to forget that. Yeah, I should probably. Okay. Okay, now it should work properly. I don't know why it's still on the words, whatever. I'll take care of that later. Okay, good, that's what I want to see. So data cable 1, or cable 1 is up. So, wait, 50 ticks so I can get back so I don't move with it, so I can actually see it move. 50 ticks, then put 1 on IOX. Okay, and it works. And I will do testing for the other motors. You guys will want to test each individual cable yourself and define constants for each color like I did the others. Just put a lever next to it and make sure your computer output is zeroed. You don't want your computer transmitting anything, because that'll corrupt it when you try to fetch the signal using the expander. So put a lever, turn it on, and then fetch it. What color was that? Okay, so this will be up. Yes, that'll be up. So, okay, and then you just want to do that for the rest of those. And okay, so I have all of my wires calibrated and named, as you can see on the screen here. Had a bit of a borg up there. They are all defined, and I just tested it. And actually, as you go back, I did make a mistake. The thing that I called up was actually down, and I forgot this wiring here. And of course, those mistakes were intentional, because I want to give you guys a challenge. Okay, so to programming. So to create the move command, I'm just going to assume that you guys are familiar with Forth. If you don't, go to the integrated redstone tutorial on Wikispaces, link in description. It is a great tutorial if you're familiar with programming, and if you're not familiar with programming, just learn it. It's more fun than you think, and just knowing how to program, even if you don't know it, is just really neat because it changes your way of thinking about things. Okay, so you want to use hexadecimal because binary makes no, decimal makes no sense at all. The only reason we use decimal is because we have 10 fingers, and even then you can count in binary using your fingers and count up to 2 to the 10th. So there's basically no reason to use radix 10. So just use, especially since dealing with computers, use hexadecimal, or I will slap you. Define move, and I already have the up, down, forward, back constants and prep constants defined. Okay, so gonna make a do loop that incorporates a thing, and I leave that first parameter blank because that will, or the first instruction blank because that will be on the stack. Okay, so let me think. Since it always preps first, this program assumes that the motors are prepped because when it ends, it preps the motors. So 0 do. Now you want to put, okay, dupe, and that duplicates the first value on the stack. Otherwise, it will take the value because calling the IOX command, it pops the value off the stack and doesn't return it, so you want to duplicate it. And then when another important thing is when the computer is being moved on a frame, it is frozen. So you only want to pulse this. I do 4 ticks because it's just conservative. That is about the amount of time it takes for a redstone signal to activate. I think it's slightly less, but it's just be conservative because of lag possibilities. Okay, so that will, it assumes they're already prepped, so now you prep them, then 18 ticks, give them time to move, and then, is that the end of the loop? Yes, it is. It's a very short and efficient loop, and that's why I said it's really nice to write software for, because the design just allows it to move right along. Okay. And now you want to get rid of the value on top of the stack because the dupe commands leaves an extra, and it's not essential, but if you want to chain commands in certain ways, what is the command? Let me find it. Drop. Okay. And then, oh yeah, it's good practice to 0 IOX. And is that it? Yes. Okay, so test it. So it takes the first parameter will be, because stack notation is backwards, the first parameter is the direction to move. So I want to go forward 2, move. It's embarrassing me. Why you do this, computer? Move. I think it wasn't prepped, that's why. Yeah, it wasn't prepped. Okay, and you can also, there's multiple ways to do this. You can do up 1 move, down 1 move. That will take you up 1, then down 1. Or you can use the stack, because the way I optimized it for stack use, you can do down 1, up 1, move. And since stack is backwards, that will go up, then down. As you can see, it's really easy to do. It's a nice, compact command. It moves along pretty fast. I'll just do and you can see how fast it moves along compared to some of the other designs, because there's very little wasted time. I could probably optimize it even more. Instead of doing 18 ticks, I might be able to bump it down to 16, which is the minimum time for a frame motor to be moved. And the vortex, like I said, I could drop it down as well. It's a very nice compact, and I've done this through trial and error, kind of. Well, no, refinement. But yeah, I've been derping around with this for quite a while, and this is definitely the best thing to do. And you can just toss this into a program, and it works really nicely. And again, I did this all from like memory. I didn't have to reference anything at any point in this, and I've done barely less than 10% of this video has been edited out from mistakes I've made. So it's a really simple design. You don't have to memorize any schematics, and it's just nice and compact. If anyone has another similar design that they think can make better, like they found a different way to wire it, or like something funky where say like these twisted these 90 degrees and it makes the wiring work better, though that wouldn't make sense, but something like that. If you have a better design, or if you make something cool with this motor, then send a video reply or post in the comments. And be sure to check my channel and maybe subscribe for updates. I will be showing the World Eater, and my next video I'll be doing a test to demolish that volcano. Should be pretty awesome. Okay, this is pretty much my first like official video, so hope you guys liked it.